Next, we are going to discuss on edge computing. So for now, we discussed on fog, the pros and cons, and we also compared the fog with the cloud computing. One more computing which also facilitates the performance is IoT is that edge computing. We'll see what is edge in next few minutes. So this edge computing will be introduced much closer to the device than the fog computing. So this diagram which is there in front of you, it gives where the edge computing is located. As you see, the edge computer is much closer to the sensors and the control. And after edge computing, we have the fog computing. It is very closer to the cloud computing. As I said, this fog computing is always close to the end user, and the edge computing is always closer to the sensors or the controllers. As you see from the diagram, the data which is generated from the sensors or the controllers will be directly going to the edge layer. And in edge layer, we can do the large volume of real-time processing at sources can be done. And on premises, we can also use some of the data visualization techniques. And from the edge layer, it will go to the fog layer where again the local network data analytics and reduction amount of data which has been transferred to the cloud can be done. Some kind of filters can be done. Again, from the fog layer, it will be communicating to the cloud layer, which really do the big data processing, and some really great business logic can be done only at the cloud computing. If you can see, you can also divide this cloud, fog, and edge computing layer based on the processing speed and the response time. If you can see, you can split these three layers based on the processing speed. You can expect a quick processing time from the edge layer, and we can also expect the quick processing time from the fog layer. But then the processing time, otherwise, you can say the response from the cloud will be much slower, because data has to travel along the way from the IoT device to the cloud. Again, it has to process the response. The response will be traveled from the cloud again to the IoT devices. So the processing and the response time will be much slower in the cloud compared to the fog and the edge computing. So from this figure, we're able to understand that the edge computing will be closer to the sensors, okay, and the fog computing will be much closer to the cloud computing. Why we need cloud computing for IoT? Again, this question arises. Why really without this we cannot be able to function? We'll see why we need it. So now you know information is built, and explosion of data in the past 5 years is unimaginable, beyond our imagination. And these data generated from these devices, which is connected to the internet, that is IoT devices, it's of huge size, call it as a big data. So traditional model processing of the data, traditional method which is used to handle the data and storing the data in the cloud, it's become very costly, because data will be generated, as I said, it is in zettabytes, 10 to the power 21. So that is what we are going to, that is how the data is being generated every day. And often if you want to store all this data in the cloud, again, it will be very costly. And often it will also not meet our requirement, because if you store all this data and if you want to process it, the response time will be very high. And we cannot afford to use those responses, which is very delayed for the real-time applications. So it is very costly and it is very slow to meet the requirements of the user. Somehow we need to improve this response time. Somehow we need to minimize the data which is stored in the cloud. So one such rescue like fog computing will have is that edge computing. This edge computing is motivating towards the processing the data closer to the sources. Instead of storing all the data from the IoT device to the cloud and then processing that, we can have a filter at the device level itself. We'll have a very closer layer called this edge layer, which is closer to the IoT devices, and it will filter some of the data which is traveling to the fog layer, and from the fog layer to the cloud computing. So this motivates to move forward an edge computing approach that facilitate the processing at the device data closer to the source. So one such command issued by the Gartner Group. The Gartner Group is a great research company which really works on the business intelligence. States that around 10% of the enterprise generated data is processed outside the cloud computing now, as of now. By 2022, Gartner predicts that 75% of the data will be processed at the layer which is close to the IoT devices. That is what it has been predicting. Now only we use around 10% of the data will be processed at the edge computing. That is how prevailing now. But in 2022, next 2 years, we can see 75% of the data which is generated from the IoT device will be processed outside the cloud computing centralized part. That is what Gartner Group predicts. The change to the edge computing may be profound impact on IT organizations and how the new digital product are built. This introduction of IT computing will have a greater impact and it will enhance the usage of IoT devices in all sectors. We'll see in the next few slides about the advantages of using the edge computing. So the key consideration of the edge computing is to overcome the network latency. The main advantage is that to overcome the network latency. Latency, as I said, the summation of requests and the response received from the server, which should be very, very fast. We should get an output at a matter of seconds. To improve the network latency, only we have this edge computing. That is a primary advantage. And of course, we have some of the derived advantage also. We'll see that. So the IoT application requires, for example, it's a real-time application, IoT application requires a very quick response time. Then this introduction of edge computing will facilitate that. So if IoT application requires sub-second response time, you have to get the response within a second. That is called sub-second response time. Then waiting for the request to the cloud may become an issue because it has to travel a very long distance to reach the cloud. And again, we have to apply the analytics on the cloud, so it will take much time. So for instance, for safety critical applications, we can use this edge computing, which will give a response to the user in a matter of seconds. Next, second is that the processing of human recognition by a sensor and processing of a decision to stop a machine cannot be delayed only because of network interaction. The delayed response from this IoT computing platform will even cause a death of a human. Imagine that you have a smartwatch and you have a critical ECG variation in your heart. Imagine this data has to go to the cloud and the cloud has to process it and it has to raise an alarm to your family doctor. It will take some time. By the time you get an heart attack and you may die. Then the ultimate purpose of having this smart device is itself will ruin. In order to eradicate that, we need to introduce some kind of computation ability at each layer in edge computing. So what does it do? It will get a quick response. If we have edge computing and if there's a huge variation in cardiac signal that is detected by the smartwatch, immediately this edge computing, which is very closer to the smart device, will be able to perform some quick analytics and immediately a family doctor can be conducted so that you can save a human's life. That's why I say a delay response from these IoT or smart devices can be very serious. It can cause a death of a human. So this introduction will give a quick response to the end user. Similarly, automated vehicles or for the augmented reality applications, we need a response very, very quick. The response has to be done within 20 milliseconds. As soon as you submit a request, the response has to come within 20 milliseconds. That is how this autonomous vehicle or augmented reality application works. Autonomous vehicle, you know, the driverless car in US. You don't have a driver. You put the destination and it will reach your destination based on the smartness in it. So for this smart vehicle without driver, the response for the request with the submitter should be less than 20 milliseconds. If we have only this cloud computing in an IoT platform, then we cannot expect the response in 20 milliseconds. It will take few minutes to get the response. But with the introduction of this edge computing, we can be able to get a response in the IoT cloud computing platform below 20 milliseconds. That will enable us to use this IoT in autonomous vehicle and in augmented reality applications. Next is that cost is also a deriving factor for the edge computing. So the bulk of telemetry data that is generated by the sensors is likely not relevant for the IoT applications. For example, imagine that you want to measure the temperature of a room. Of course, the temperature has to be measured frequently by the sensor. It has to measure the temperature frequently, maybe for 15 minutes or for 5 minutes you have to measure, and then it has to get upgraded. Whenever the temperature reaches below the threshold or above the threshold, then definitely you have to do some actions. So the fact, if you have a temperature sensor and you said that if the temperature rises above 40 degrees, then you have to switch on the AC. That is how you have designed your smart home appliances. So what will happen? The temperature sensor, for every 5 minutes, it will record. That minutes can be varied. It can be for 5 minutes or it can be for 1 minute. For every periodical intervals, these temperature sensor will record the temperature and it will be stored in the cloud. And these data, it is of no necessity because For example, if for a whole day the temperature of room is around 20 degrees Celsius, then it is of no use to store those data in the cloud. Unnecessarily, you will have to pay for the storage. If we have a small intelligence in the edge computing, like if the temperature is greater than or equal to 40, then forward the data to the cloud. Otherwise, drop the data there itself. There's a very simple logic that can be put it in the edge computing that will prevent the unnecessary data, that 20 degrees Celsius data, to be stored directly in the cloud. Instead, only the data which is above or equal to 40, that can be stored in the cloud for further processing. That's why it said the fact of a temperature sensor reports 20 degrees Celsius for every second may not be interesting until the sensor reports 40 degrees Celsius. So these kind of unnecessary data can be prevented by putting a simple logic at the edge computing devices. And edge computing also allows the data to be filtered and processed before it's sent to the cloud. As I said, if these 20 degrees Celsius data can be filtered itself, you can drop the package there itself, and that those data need not be communicated to the cloud platform. And only the very sensitive and crucial data need to be sent to the cloud for storage and for further analytics. This edge computing also reduces the storage, as I said, cloud storage and processing costs of the data that is not relevant to the application. That's very, very important. We filter the data at the edge computing level itself, the storage will be reduced, network traffic will be reduced, and also the processing of the data at the cloud will also be reduced. Ultimately, users will get benefit out of it. These are some of the other advantages of edge computing is that deploying analytics algorithm or machine learning algorithms at the edge computing layer. Since I said this edge computing has a minimal amount of processing capacity, we can also deploy some of the very simple analytics and machine learning algorithms to be performed at the edge computing layer itself to give a quick response to the user. Edge computing will be more computation efficient to process the data. And many more digital products need to be autonomous in their operation. So this edge computing will allow to achieve required safety, reliability, and user experience needs by introduction of this edge computing. And edge computing also provides the ability to have a local storage and local computation. As I said, it has limited storage and local computation can be done with that kind of processing capacity is there in the edge computing. Thereby, the device can continue to function even if it is not connected to the network. The cloud, for using the cloud, you need to have a dedicated network connection. But then for this edge computing, you need not have a network connection. By using a simple lightweight protocol, the device can able to communicate with edge computing and it can able to get the response. That's really an advantage of this edge computing. And another advantage of this edge computing is that privacy and security. Privacy and security, of course, is a very big issue in IoT applications. But this we have edge computing. This has been slightly improved. Security and privacy of IoT application has been slightly improved. Edge computing can reduce, how we can see the edge computing can reduce the number of sensors and the number of actuators connected to the internet. That itself will save your data. If a sensor and actuator directly connected to the internet, then your device can be easily compromised by the hackers. Many number of ways by which your devices can be easily compromised by the hacker. The data from the sensors can be modified and it can be sent to the user and can be stored in the cloud. Again, if you do analytics there, it will lead to a business failure because your sensors are connected to the internet, and internet is a place where for hackers to play around with. So if you prevent your sensor directly connecting to the network, then that itself will giving a little amount of security and privacy for your applicants. Okay, so this preventing the sensors and actuators connecting directly to the internet itself, which enhances your security and privacy in IoT applications. And the last, it can able to do the local data processing and filtering and storage, which will only give a quick response for the sensitive applications. These are some of the advantages of edge computing. I want to see the cons. If you see what are the cons in edge computing again. Again, on one side we have said it is also providing security, but on the other side, there are also some pitfalls in the edge computing security mechanisms. It ensures adequate security can be often challenging in the edge distributed environment due to the fact that data processing takes place outside the edge of the network that are often at the risk of identity theft and cybersecurity breaches. Additionally, when a new IoT device is added here, it will increase the opportunity of attacker to infiltrate the devices. Again, if you keep on adding the new devices to the edge computing, then that can be breached by the hackers, and again, a lot of theft can happen for your data. And incomplete data is a very, very important point here. See, as I said, you can put some kind of filtering also in the edge computing. This filtering will avoid unnecessary data traveling from the IoT devices to the cloud. And this unnecessary data will not reach even the cloud. These will be filtered and will be dropped at the edge computing layer itself. These data are simply discarded. But what the analyst says is that the data which is being discarded will also contain some amount of useful information, and you will be losing that if you do the filtering process at the edge computing. That's what this point says. Edge computing only process and analyze partial sets of information based on the filters you applied at the edge computing. The rest of the data just discarded. And the analyst says that if you discard the information, then you'll be using some of the valuable information, and therefore organization may not able to get the complete intelligence from the data. This one's a disadvantages. If you discard, obviously you're going to lose some information. And of course, on the other hand, we can able to save the space in the cloud, but on the other hand, you will use some of the valuable information. And next is that more storage space. Edge computing does take considerable high storage from your devices. So it will use some of the storage space of the devices because it has to do the data analytics, and for data analytics, you need to store the data somewhere. Of course, it will use the space of the devices that you cannot avoid. And cost is one big thing which we have to worry, because this is an edge infrastructure. Deploying edge nodes will be costly, and it is also complex. So making the network complex, so it will involve some amount of cost. So these are the disadvantages of edge computing. The last one is nothing but the maintenance. As the more number of nodes are being introduced at the layer which is closer to the sensors, it complicates the network, and then maintaining the network with several computing nodes itself is very, very costly. This requires higher maintenance cost than the centralized infrastructure. Than maintaining the cloud, this introduction of new nodes, which is very closer to the sensors, will have much maintenance cost. These are some of the disadvantages of cloud computing. Edge computing, sorry. Now we'll have a quick comparison of why we need cloud, edge, and fog, and we're going to compare this on different parameters. The main difference between the IoT device or the applicants communicating with the cloud server is that the cloud is always a bidirectional communication. Whenever the data IoT devices generate the data, it has to travel along all the way to the cloud, and in turn, cloud will do some kind of analytics or analysis. Then it has to send the response to the sensors, and that will be displayed to the world through actuators. It is a bidirectional communication that will take some amount of time to process the request, and the response will come back to the user at some amount of time. While it may take some few milliseconds if you when interacting with the nodes which is placed to the devices. So cloud computing, as I said, it will take some minutes, whereas if you place this like edge and the fog, if you place in between the IoT devices and the cloud, it will take only few milliseconds to process or do some minimal amount of analytics, and the user can able to get a quick response. That's the main advantage. Next, while cloud computing still remains the first preference for storing, analyzing, and processing data, and companies gradually moving to the edge and fog to reduce the cost. In what way? As I said, these edge and fog computing devices will have an intermediate layer, and this intermediate layer will filter the data at this edge and fog itself. So the unnecessary data which is not relevant, those things will not be stored in the cloud computing, so that you can reduce the space in the cloud. And of course, the processing capacity of the cloud is also saved. In turn, it will result in cost reduction for the producers. So the fundamental idea is adopting this to architecture is not to replace the cloud computing. As I said, this fog and edge are not competing with the cloud to replace it. In turn, this fog and this edge computing are facilitating the cloud computing for its very smooth function. That point you should always keep in mind. And smart applicants and IoT-based devices require instant decision making. This IoT itself, we expect to act in real time. So if somebody requires the responsibility in a quick manner. And while companies are adding new, enhanced, and much better features, they help in quick decisions. But without introduction of this edge and fog, there will be a latency, or there will be much time in summation of getting a response. So this cloud and this edge and fog will really have helped the application to get a quicker response, because it has some computation ability at the layer itself. Both edge and fog computing are meant to deal with only one problem: the optimization and performance. That is what the main objective of this edge and fog computing, to optimize the performance. While edge computing is widely preferred, this edge computing is mainly preferred by the middleware companies and the telecom companies that work mainly on the network, because this edge computing will reduce the traffic in the network. So this edge computing will be focused only by the telecom companies, which works the network, it is the backbone. And the fog computing, it is mainly preferred by the data processing companies, because this fog computing is closer to the cloud computing. So this fog computing is mainly preferred by the companies which is doing the data analysis, and its service provider will prefer the fog computing, whereas edge computing is mainly preferred by the telecom companies. And it is not an easy task to incorporate fog or edge computing in an organization. For example, if an organization use much time the cloud computing, then if you want to introduce the edge and cloud system in it, it is not that an easy task. But then definitely the changes has to be accepted by those organization in order to have good latency. However, the need for collecting huge amount of data, especially in the age of this 5G networks uh, and its speed, the companies might have to push the boundaries to adapt these technologies. Otherwise, they'll be far behind and they cannot cope up with the advancement in the technology, and they can't give a tough fight with the competitors. This is a quick comparison of edge, fog, and the cloud. Again, I would like to present this picture. As I said, this edge layer will be close to the IoT devices or the sensors. The fog layer will be close to the cloud computing. You have to know where the edge comes and where the fog layer comes. This is very, very important. Please note, I will look at it once again. Next, we're going to see, so far now we have seen the current trends. And if you want to do some research in IoT, there are a lot many avenues where you can play in your expertise in IoT, because it involves cloud computing, it involves data analytics, it involves machine learning, it involves artificial intelligence. So you can play around with many kind of specialization in the area of IoT. For example, I have given some of the layers of the network and some the topics which to be focused. For example, the physical layer, you can have smart devices and sensors. You can work as sensors, which is really workable or suitable for the real-time application. And data link, you can work on really the protocols like Bluetooth, Zigbee, and you can also work on how this can be modified further for a quick response time. And routing, I know you know that this IoT is totally working on this mesh network, and how this effective routing can be done in this IoT scenario. And analytics, you can have good machine learning algorithms. You can develop a very effective machine learning algorithms or predictive analytics, or some of the data mining algorithms that can be, you can work and you can focus on your research. And you can also work on this cloud computing and web-based collaboration, and especially how this cloud can able to process or analyze the data and able to give a quick response time. Now, as its general scenario is there, the cloud computing, if you do analysis with the help of IoT devices, the response time will be very high. But then you can work on how this response time can be very small, so that you can really apply with the real-time application. You can do a research on that. And as I said, on improving the latency in the response time, you can also apply this IoT with real-time applications. And many research also being going on the edge and fog computing. If you see, there is a paper on 5th 2017 by Stefani on addressing cybersecurity challenges proactively to ensure success with outsourced IoT devices. This paper presents a survey that shows why this IoT is not being adopted by majority of the industry. So what makes them not to follow the IoT? That is what in other words. So this is the graph which depict on the x-axis we have the respondent, and the y-axis we have various reasons for many industries not adopting this IoT. The first reasons why the people are not going for this IoT is that security concern. The security concern is the biggest drawback in IoT devices, in IoT computing, so that it is preventing many of the industries to adapt for their business purposes. That is why the security concern we see 49% of the people are really feel that they don't have any safety if they use IoT for their business. That is what preventing them. Almost 50 we can say. This is one of the major criteria which is not letting this IoT to be used extensively in the industry. The second reason for not IoT being so popular in the industry is that privacy. I hope you know the difference between the security and the privacy, right? If I access the internet, if my credentials are hidden, then I can call it as a privacy. And security means if I want to transmit some information to the counterpart, if the information are not seen by the in-betweeners, it is only read by the counterpart, then we can call that as security. And the third reason is that lack of compelling business cases. And fourth is that obtaining staff and skills to create IoT strategies and system. The fifth factor which is preventing from the industry to get into this IoT is that dealing with new and untried technology and service provider. And six is that risk associated with the business change and new business models. Seven is that workforce resistance, new technologies, practices of process. The last one is competitors will be more innovative or more rapid in the exploitation of IoT data. These are some of the reasons. And if you list out from the top, we can easily address that security and privacy is a major concern of the industry to venture into this IoT. If you address this issue, then that itself is a very breakthrough, and that will pave way for many industries to use IoT. And one such example why industries are a little hesitant to venture into IoT. This is a small example. Recently, a conference, the Black Hat is Black Hat is a conference that is being held annually by the hackers. And recently, in this year, it is planned on 29 September to October 2, I think. So for a 4 days conference of hackers. And the last year, few years back, I think, they have demonstrated how they hacked the smart toilet. So what it does that somehow they hack the devices which is controlling the smart toilet, and they make this toilet flush at many times, and the lid shut many times by hacking the controller which is controlling the smart toilet. So by making this, they make this toilet unusable. They have shown a live demonstration in this Black Hat conference. This is one such security breach which is being done in the conference. So this kind of threatness is keeping away the industries to venture into this IoT. So what are the ways, what are the avenues by which these hackers entering into these IoT devices and making it less secure? That is what we're going to see. The first main target of this hacker is the IoT devices. As IoT devices are very simple and they are very designed for only specific tasks, we don't have much computing capacity, and hence we will not be able to incorporate much of the security firewalls in it. That is the reason that hackers are focusing on these IoT devices, and these devices can be easily compromised by the hackers. The first avenue where this hacker is provoking or intruding is that IoT devices. That is the first one they are targeting. If they compromise the IoT device, then the rest is very easy, because if the data originate from the IoT devices, if they touch the origination of the data of these IoT devices, then they are done. And of course, IoT devices are very simple, so that is very easy to hack. So that is a primary focus of the hackers, IoT devices. Next, they are focusing on the technology by which the IoT is communicating with the edge computing layer. I said this can be done without internet, like the small protocol, Wi-Fi and Z-Way. So they are exploiting the protocol. First thing they will try to compromise the devices. Second level, they're trying to compromise the technology by which the data has been transmitted from the IoT devices to the edge computing layer. The third way, they're trying to compromise the IoT gateway. And the fourth one, they are trying to compromise the network by which the data from the edge computing or the fog computing, how it is trying to go to the cloud. Of course, through internet. So they're trying to compromise the Wi-Fi and there is routers. And the fifth, they're trying to compromise the cloud. And if they're not still able to compromise the cloud, then they're trying to compromise the interface from the cloud. So these are the priority list of the hackers in which they will be targeting these IoT applications. Next, we are going to see the top 10 security big challenges faced by the researchers in the Internet of Things. As I said, security is the major concern. If you are working on this security issues in IoT, your research will be most highly cited, because there is a need of the hour, and there is a much exploited and a much needed area for the industries to work on. Many people are working on these IoT securities, and I also invite you to explore more on that so that your research will be on the limelight. The first security challenge is that insufficient testing and update. Most of the devices, IoT devices specifically, they are not undergone extensive testing and they are not upgrading it. This is the first reason that IoT devices are compromised very easily. They are designed only for specific purpose, but sufficient testing are not being done by the companies or not done by the manufacturers. That paves way for them to easily fall prey for the hackers. And there is no frequent update for the IoT devices. See, when you update a device, whenever you find some pitfalls or whenever you find there is a some security loophole, then immediately you will have a patch file to make sure the security loophole is not there. But many of the manufacturers of IoT devices are not bothering about their updates. Once their device is being marketed, they are forgetting and they are working on some other devices. That is the issue why these IoT devices are easily being compromised. Second security challenge is that brute force being an issue of default password. Every IoT devices will have a default password. Admin is the default password for IoT devices. So many of the users are also not changing the default password. They are just buying the devices and using the password as such. That is one of the reasons. Even if the password is changed, it can be easily brute force. It's the second biggest chat in the IoT issues. The third one is the IoT malware and ransomware. You know, IoT ransomware, right? Ransomware is a kind of attack by which the hackers can able to encrypt all your data. And upon paying some amount of dollars to them only, they will decrypt the data so that you can view your files. That is possible if your IoT device is having a loopholes. IoT botnets aiming at cryptocurrency. Botnets are like a master-slave working model where the master will be somewhere and the slaves will be in a system. Based on the command from the master, your slaves in your system will be acting and it will not able to do any productive work. Again, only upon summation of some amount of currency, this will be done. So data security concerns like data traveling between the edge computing and the cloud, again, is a big concern. And small IoT attacks, that is IoT attack in the sense that will work on the protocol, IoT protocol, again, that will have some rule and that will also pay way for attack. And artificial intelligence and automation, it also paves way for some of the security challenges and home inventions, remote vehicle access, and untrustworthy communication. These are some of the 10 big security challenges that is faced with researchers in the Internet of Things. So security, we can summarize quickly that security is the main area that has to be touched with researchers to work on. So now we are coming to the end of this fifth day webinar, and I will quickly summarize what are the takeaway points from this 5-day webinar. In the first, the day one, we discussed extensively on what is IoT and what are the by which we can call a device an IoT device, and we also given some examples of how this IoT makes human life so much sophisticated. We compared how IoT is different from the computers, and we also discussed in brief about IoT visions and the growth. The second day of webinar, we had a detailed discussion on architecture, characteristics of embedded system. We also discussed on various IoT platforms. We also compared some of the top IoT platforms like Raspberry Pi and Arduino. On day 3, we discussed about IoT, big data, and the cloud and the relationship between them. We called IoT as a king, big data as a queen, cloud as a palace. We had a brief discussion on IoT analytics lifecycle, and we have also discussion on how this IoT cloud platforms plays a crucial role of storing the data and analytics has been done. And 2 videos has been played on IoT IBM Watson platform, how data has been collected and how this has been analyzed. We also had a brief discussion on visualization techniques. And on the day 4, yesterday we had a discussion on how these IoT devices are connected with the servers and what are the different IoT protocols are available and comparison amount. Today we see the current trends, that is we discussed briefly on edge and cloud computing, the pros and cons. And we also discussed what are the various research problems that is open in the Internet of Things. This is what the quick points that we're going to take from this webinar. So the feedback, I sincerely suggest you to give the feedback at the URL which is mentioned there. So please make a note of this URL, and I all request you to submit the feedback by today. By this feedback, we can able to improve. If there is some more webinars shortly going to be organized, and based on this feedback, it will help us to improve the experience for you in the forthcoming webinars. So I request you to give a webinar. Don't worry, this feedback doesn't have much fields. It is only having one page with 7 fields. It's very simply designed feedback form. So I request all you to submit this feedback form that will help us to improve the webinar, the forthcoming webinar. Please do this link which is mentioned there. It will not take more than 2 minutes. So please spare 2 minutes for us. That will help us to do much better for you. So if you have any questions, you can email me at tiago@cutn.ac.in. You can call me at 9488584015, or if you want to WhatsApp me, you can WhatsApp in 98412345110. Already I started getting many mails. I sincerely thank you for a very positive feedback. And even if there is any negative, please feel to email me so that that will be rectified in the further webinar, which is coming shortly. These are some of the references, and the web resources has been lavishly used in this 5 days webinar, and I sincerely thank the various sources. And once again, very thank you for you all for a patient listening. And before winding, I like to place my thanks on records to Professor M. Ravichandran, Director in Charge for this Bharathasan University PEC. And my sincere thanks is also due to Dr. N. Prasanna, Deputy Director in Charge for this Bharathasan University PEC. And I also thank for all the staff who is working in Bharathasan University PEC for their support in making this webinar a grand success. Once again, I sincerely suggest and request you to give the feedback of this webinar at the URL again mentioned at here. It is pretty much short URL .at/b capital G capital O08. Please give your feedback here, that will help us to reach you much better the forthcoming webinars. Once again, thank you so much for your passionate listening. Thank you.